Okay, today we are going to talk about points, lines, and planes. These are all the basic concepts of geometry, and you have to have a really good foundation and understanding of these in order to be successful throughout the year. Points. First of all, points truly do not have a definition. There is no width, there is no thickness, so someone might make a point like that. Someone else might make it a little bit bigger. It doesn't matter. It's still labeling it as a very specific location. So a point is a specific location, and we label it with a capital letter. It does make a difference. So I know some of you write things in capital letters. Some of you write them in lowercase letters. It does make a difference in geometry, and you have to make sure that you are aware, is this supposed to be capitalized? Is this supposed to be a lowercase? So if I'm talking about point E. Okay, so you have a point with a capital letter. We have a line. A line is a straight path. That extends infinitely. And infinitely means forever and ever. Infinitely in opposite directions. Now, the way that you determine a line is a line is determined by 2 points. And a lot of times I'll abbreviate points PTS. So any line is determined by 2 points. So if I have point A here and I have point B down here, I could draw a line through those 2 points. I have line AB. There are several ways of labeling a line. You could say that this is line AB, and we have symbols. It has to have a little arrowheads on the end because that says that it keeps going forever and ever in opposite directions. You could also have line BA. Again, you have to have the little arrows on there. And every once in a while, you will see a lowercase capital letter, or excuse me, a lowercase cursive letter, and that is also notating the line. So we could say line L. So any 3 ways there of identifying a line. So through any 2 points, there determines 1 line. A plane is a flat surface that extends infinitely in all directions. Extends infinitely in all directions. Just like a point and a line, there's no thickness, there's no width. So if we go back to line AB, this might be a glob of paint. Maybe there's a glob of paint here and a glob of paint here. Maybe it is like the end of a pen. So if I have 2 pens, the end point is the actual point that would determine the line. So a plane extends infinitely in all directions. Now, in order to draw or represent a plane, typically we show it like a parallelogram. Okay? An example of a plane would be the floor of a classroom. Now, if you look at the second floor at Lewis Central High School, the floor it looks like it's, stays within the door, but you can go out the door, you can go into the pod, it kind of goes out into the hall, but it does extend infinitely in all directions, and even if there's a wall there and it looks like it stops, there is still a plane that exists. So it's a flat surface that extends infinitely in all directions. Just like a line and a point, there's specific ways of labeling a plane. You could have 3 points, 3 non-collinear points. I'm actually going to define that here in a minute. 3 non-collinear points. So if this is point A, and this is point B, and this is point C, I could call this plane ABC. I could call it plane BCA. It wouldn't matter. If I chucked a couple more points in here, E and an F and maybe a D somewhere, I could use 3 points, non-collinear points. A, D, F. They do not form a line. Okay? So I could name it with any 3 points. Just like a line, when we have a lowercase cursive in a plane, sometimes you'll see a cursive capital. So I could say maybe this is plane R, because that is supposed to be a cursive R. You just can't see it very well. Okay? So you can label it with 3 points. Even though there's 6 points here, you still only pick 3 of them. Okay? Now, I've mentioned the word collinear. Collinear means on the same line. So there's that word line hidden in there. On the same line. So if I have points, M, N, P, Q, and R, for example, those are all collinear. They form, or they are on, rather, the same line. If I were to add point T out there, T is not collinear with points M and N. T is not collinear or non-collinear with points N, P, and Q. It's not on the same line as the other 3 points are. And then we have coplanar. Much like collinear is on the same line, coplanar means on the same plane. So if we have point M, N, and P, let's visualize this as being like the top of your desk. Points M, N, and P are coplanar because they are on the same plane. Now, I'm going to add something to this diagram. See if you can figure out what it is. Okay, so if we have something like that, see if you can figure out what it is. What this is equivalent to, let me see if I can get a little visual here. So if we have the plane of this piece of paper, and I have a line going through it. Okay, let's see if I can get this right. Okay, so if I had the plane of the paper, and I have a line going through it, this point, it's on this line, but it is not in the plane of the paper. And that's what you should be visualizing here. Part of the challenge with geometry is the visualization of 2D and 3D. Okay? So that concludes the first part of definitions.